All right, guys, so we're going to do 7.2 today. It's really just kind of continuing to develop the ideas that we learned last time, but just kind of stretching what we do with it a little bit further. So here's what we learned last time. Last time we talked about these things, and you really don't need to write this down because you already have it, but we learned about these things called rate in and rate out problems, okay? And how they work. It looks like it says dut, but it means out. So how it works is that if you have something that is having stuff put in and stuff taken out simultaneously, in these problems you're going to be told the rate at which it's coming in, and you're going to be told the rate at which it's going out. So we have a rate in as a function of time, and we have a rate out as a function of time. And the total rate would be what you get if you subtract those. Bless you. Rate in is adding stuff in, so it's positive. Rate out is taking stuff out, so it's negative. So when you put these rates together to get a total rate, it's in minus out. Okay? Now, the big idea that we learned last class was that if you take the rate and you integrate it over a certain period of time, with respect to time, then that will tell you the total amount of change that has taken place. We called it the net change. So for instance, on number 6 on your homework, the car question, they graphed the speed for you, right? And said, how far did the car travel? Well, if you integrate the speed over the time interval that they give you, that will tell you the total distance that the car traveled. How do you integrate with a graph? You find the area under the curve. And so that would have been how you do number 6. Now, what you do then is that's your net change. And usually you're going to have a starting amount. I'll just call it F. The starting amount is, I'll call this A, by the way, not 0, because it's not always 0. The starting amount is whatever your function's value was at A. So if you take the starting amount and you add to it how much change has occurred, that will tell you the final amount. So the final amount is equal to the starting amount added to the net change. And so we have this little formula here for calculating outcomes using integrals, okay? So that's what we learned last time. And so today we're just going to do this worksheet where we kind of look at the same formula here, the same basic setup, but just in different contexts and different types of questions I could ask with it, just to kind of get you guys really familiar with it. All right, so let's go ahead and begin our little worksheet here. I'm going to be doing example, and then you guys do a practice, and I'll do example practice. I'll close this out for the day. Each example has a bunch of different stuff in it. So let's go ahead and take a look at our problem here. We have at 7 a.m. there are 500 bees in the hive. Now don't read the rest of the sentence. Don't stop. Don't read it. At 7 a.m. there are 500 bees in the hive. 7 has to be what? Yeah, that's your starting time. So on number 2 on your homework, remember how it said the time from 1 to 4? Well, 1 o'clock was t equals 0. That was your beginning time. Okay? And so a lot of you guys probably did integral 1 to 4, but it really should have been 0 to 3 because it was from the first time, which is 0. 1 o'clock is t equals 0. 4 o'clock is 3 hours later at 3. So the integral would have been from 0 to 3. But anyway, at 7 a.m. there are 500 bees in the hive. What do we call that? That's our starting amount. And that little formula I wrote at the beginning, that's your f of a. So 0 is going to go on the bottom of my integral, and 500 is going to be the little number in the front, right? So from 7 a.m., which they were kind and told us that's t equals 0, to 5 p.m., they don't really need to tell us that. We should be able to figure that out, but they're nice, and so they're telling us. Why shouldn't they have to tell us 5 is 10? Well, because start at 7, that's 0, 8, 9, 10, 11, 12, 1, 2, 3, 4, 5. You should be able to actually figure that out, that would be t equals 10, right? So but they're nice, and sometimes they are nice. The bees leave the hive at a rate given by this. So if they're leaving the hive at that rate, what do you guys think that is? Is that my rate in or rate out? Rate out. That's the one I'm going to minus in my integral. Okay? Where t is measured in hours after 7 a.m. So just so you guys understand, well, we'll probably look at that. Let's read on. The rate in bees per hour that enter the hive is given by this. Now I'm deliberately giving you weird functions because we're just going to be using the calculator today. So the calculator is going to do all the hard math for us. But really, so for you guys, it's all about the setup. And by the way, when you're doing FRQs, you could do everything on the calculator and just write the answer. You'll get a 0 though. With FRQs involving calculators, you must show your setup that you put into the calculator. Okay? Then you can put your answer. But you can't just put your straight up answer. They won't give you credit for that. All right, now let's take a look at part A. How many bees enter the hive from 7 a.m. to noon? Okay, so first of all, let's analyze some stuff. T equals what? And T equals what? You got to figure that one out yourself. 5? Let's see. 8. So it's 7 is 0. So 8, 9, 10, 11, 12. 5 is right. No, so it went to noon. So you got to pay attention to your interval, right? Now the next thing is, what are they asking for? How many bees enter? Does that mean how many bees are in the hive? That does not. They're not asking how many bees are in the hive. They ask how many entered the hive. Why is that different? You're right. So here's the thing. How many bees are in the hive? That has to do with two things. That has to do with how many are going in and how many are going out. That tells you the total that is inside, right? But they don't care about how many are in. They just want to know how many went in. It's kind of like if you were in a restaurant, right? And you want to see how many customers did I get today. You're not going to stop right there and count the customers and be like, that's how many customers I had today, right? You're going to count how many people walked through the door. People left, didn't they? But you're just counting how many people came in. You don't care after they leave. They don't matter. So that's what we're looking at here. How many bees just entered the hive? So, and as Angie pointed out, if I want to find out the total change that occurred for coming in, which function am I going to use up here? You're going to use the E, the enter. Now this function here only tells you the rate at which they're coming into the hive. It doesn't tell you how many bees have entered the hive. What do we have to do? You integrate it. That's how you find a total change, a total amount. Is you integrate the rate. Okay? So here we go. We're going to integrate the function e of t dt from what to what? That's how you're going to do it. Now, I'm not going to actually punch any of these numbers in yet. I think I'm just going to set them up first, and then we'll do the calculator work all at once. You already did the work? All right, cool. We'll get to it. All right, next one. How many bees leave the hive? Why don't you guys see if you can set that up? I'll call on you in a second to share out what you think that setup would be. Got to pay attention to your interval. Got to pay attention to what you're finding. Didn't need you, huh?
No. It was, we weren't doing anything for like the last 3 days.
Gotcha. That's right, because he's doing that community service stuff. You know, reaching out to the community and stuff, right? Yeah. All right. So James, what'd you get? Jimmy.
0 to 5 and LT to DT.
Good job. So if you integrate how fast they're leaving, then you'll know how many bees left the hive. So that's like counting how many people walked out your door. Doesn't mean how many people have left. Well, I'm going to stop there before I confuse myself. But go ahead.
Is it supposed to be negative? Is there supposed to be like a negative part?
That's a good question. I like this question. So is it supposed to be negative because they're leaving? I'm going to say no. Now here's the reason why. I like your thinking because that's relevant. But if they ask how many people are leaving, you can give a positive answer because your positive answer means that's how many people left, right? So like if I asked you how many people left your restaurant, you wouldn't say negative 70, right?
Okay, yeah.
But now if I asked you to calculate something with that, if I said how many people are in your restaurant at this moment, you would have to take how many people have entered versus how many people have left to calculate that, right? Now the lead becomes a minus. Okay. All right, so there's that. I have to erase my answers because I can't keep them on the page there. I'm actually writing on top of the document. So I'll come back to that though. Part C. Now the question is different. The question is asking how many bees are in there at noon. So now the question isn't how many entered. It's not how many have left. The question is now literally how many bees are actually inside. Yeah? Yes, good job. So for this one, what you're going to do is you're going to take the total number of bees that entered the hive, and if you subtract from that the total number of bees that left, wouldn't that tell you at that moment how many are present? Right? So let's say you're owning a restaurant, right? And you've been open for a couple hours. 100 people came in that first 5 hours. And over that first 5 hours, also 80 people left. How many people are in your restaurant right now? 20, right? You just subtract them, so you put the differences together. So here's how you do it. How many bees are in there by noon? Well, you're going to take your rate in, which is E of t, minus your rate out, and you're going to integrate that. That will tell you the total amount who are present in the hive at that moment in time. Okay?
Is that a minus in the middle?
It is, yeah. It's not a very good one, but there. No problem. Thank you for asking. Some people might have thought that was at times. Part D. Write an expression that would represent the number of bees in the hive T hours after 7 a.m. This is a very common question on the FRQs, I've noticed. They want you just to write a function. We already know how to do it. So the number of bees that are in the hive at any given time is what? Good, the starting amount, right? So the hive starts with 500 bees, right? Plus the total change that happened. And what's the total change? The integral of E of t minus L of t dt. Now, we're still not done. We've got to put our limits on here. What am I going to put on the bottom? 0. Now, be careful here. What do I put on the top? No. Because look at your question. T. In other words, they want you to write a function. If you put a number here, you're going to get an answer. That's going to tell you how many bees are in the hive at that point in time. Matter of fact, I just realized we need to go back to C. We have an error, and I'll let you guys see if you can find it. But here it's going to be T. So let me ask you this. C is wrong. What's wrong with it? We forgot the 500. This is how many bees have come into the hive over that 5-hour period. But I forgot to include what we started with. So it's 500. There we go. Sorry about that. Now we get to go ahead and do our calculator work here. And here's what I like about setting it up first. After you set it up first, you just have to punch buttons in repeatedly. So you guys can either just watch me do this, or you can participate with me. I'll leave it up to you. It doesn't really matter. You're going to get a chance to practice anyway. But I just want to show you how fast this can go, you know. So the first thing is, of course, we have to type in our equations, right? So clear your calculator out first, right? I'm going to need a little help here, though. What was, can you read me what, let's start with, I'm just going to start with E of t, the rate in first. What's the E of t function? 7x. E. 0.5 cosine x. Parentheses to close the cosine, parentheses to close the exponent. All right, cool. That's my rate in. Now let's do the rate out. What's the rate out?
3
X minus 5 to the power of 2. Is that it?
No, and then like
Plus 1?
no, plus the next. Like it's not going to be in.
Oh, so on this calculator, as soon as, unless I put that 2 in parentheses, the plus means it's done with the exponent, so I'm good. So there's nothing else in the exponent, right? Okay, so then it's plus what? And that's it? Oh, well, just overwrote my thing. Okay, so there's that. Back to our home screen, second quit, right? Okay, so now we're just going to type in our integrals. My first integral, wasn't it how many bees have entered the hive by noon, right? And so our setup, now mine isn't going to look as cool as most of yours, but you go to math and 9, and you type in your function, but instead of typing that whole thing again and risk making an error, I'm going to go to variables, y variables, function, and I have to remember which one was enter, which one was leave, right? That's important. So I put enter as y1. So y1, comma, with respect to x, comma, and my interval was 0 to 5, right? And does anybody else have an ugly one like mine today? You guys all have nice calculators? Okay, good. So you don't need to worry about it. But anyway, there it is. You just go ahead and push enter. Now I'm going to write my answer in. You want to put your units, though. So go ahead and write that answer down, though. It's 72 point, and we're going to round to, now here's the interesting thing. We're talking about bees. So you can't really have 0.37. Well, if you round it to the thousandths, it would be 0.38, right? You can't have that many bees. So what am I going to say? Okay, so we'll put squiggly marks, not equal, but squiggly marks, and we're going to put 72 bees. And usually on the test, just to be clear, they will say round to the nearest bee or something like that. All right, so then the next one, just repeat, right? Now check this out. I want to show you guys a neat trick. You guys ready? I don't want to type all that again. And also notice that the next problem is exactly the same. It's just that instead of y1, I'm going to put what in there? y2. So watch this. If you just got to make one change, you're going to push second entry. It brings back the whole thing again. Just come back here to this spot, put your cursor on top of that, and put y2 in there instead. That way you don't have to type it all over again. Oh, something happened. What happened there? That was kind of weird. And by the way, to insert, so I just lost my comma. This is a good learning opportunity. To insert a comma, I think I need to put it here. I always get confused if I need it there or there. Let's see. Yeah, we're good. You have to push second insert. If you don't push second, it just writes on top of it and deletes what's under it. Does that make sense? So if you push second and insert, it will insert something there. All right, so going back to y1, let me try that again. Variables, y variables, 1, and I want y2. There. So I didn't have to type the whole thing again. And this one turned out pretty clean. The answer is 130. So go ahead and put on your answer there for part B, 130 bees have left the hive. So by noon, 72 bees came in, and 130 went out. All right, the next question, how many bees are actually in the hive at noon? Well, for that, we have to do 500 plus the integral of y1 minus y2. So I think you guys have got the idea. So once you have your setup, it's just punching numbers into the calculator. You got to be really careful, though, when you're doing calculator work, that you don't accidentally, when you're writing your FRQs, call one of the functions y1 or y2. They told you what they're called. They're E and L, right? So if on your FRQ you write y1, you'll lose credit. It's unfortunate, but they will get you that way. Yeah?
Why didn't you just subtract 72 or 130 from 72?
We could have. So Pearl just brought up a good point. Why don't we just subtract 130 from 72, because that's how many left, and then take that answer and add it to 500? You would get the same answer. It would work. So you could have saved yourself some time if you're smarter than Mr. Bailey. All right. Next. Oh, the last one we don't have to calculate anything. It was just a setup. So, all right. So I'm gonna let you guys try one here. I think. What am I gonna have you guys work on? I think I'm gonna have you work on the back side. So flip over your paper, and I'm gonna give you a little while to work on student practice 2 on the back. You guys are dealing with bats and caves.
What was the last part?
What was the last problem before I deleted it? Let me see if I can bring it back for you. All right, so go ahead and work on the back. See what you guys get out there. So Vivian, what'd you get for part A? 426. Oh, you got the answer. 426. Cool. All right. So what's your setup?
10.
On the top?
Yeah.
And then 0, right?
Yeah.
And which function did you use? Good. Okay, so we have 120 bats at 6 p.m. in a cave. They're entering at the rate of E there. They're leaving at a rate of L. Both functions are measured in bats per minute, and time is measured in minutes after 6 p.m. All right. And so don't forget your units here. We do want to include our units of bats there. Do we agree with 426? I didn't work it out. So did you all get 426?
427.
427? Okay, so the number after the decimal was 5 or bigger? Okay, so it's fine. I didn't. I thought mine was 72.3, so I made it 72.
No, not for this one. Like yesterday.
Oh. Okay, so yesterday, I don't remember what we were working with. I think we're working mainly with like fluids, right?
Yeah.
And so with fluids, you can have decimals, right? And so I rounded, and the rule is in AP Calc, the thousands place. So 3 numbers after the decimal, you rounded that one. But if you're talking about things like this, like bats or something with a solid number, then you rounded the nearest one. And they'll tell you that too, usually. I didn't tell you, but they'll tell you that. All right, let's go ahead and take a look at the next one here. How many bats have left the cave by 6:10? Michael, what's your setup for this one?
Nickel, 0 to 10 again, and then LT.
And answer?
228.
Cool. Do we agree? 228? All right, next one. Graydon, part C. Sure. 300 and what? What do you guys think? We're good? Okay, now the easy way to do that is to take the number of bats that went into the cave, subtract from it the number of bats that left the cave, and add the starting amount in there as well, and you'll get your answer. If you wanted to actually set it up, though, it would look like this. 120 plus the integral from 0 to 10 of E minus L dt. Okay? So there's our answer for C. And that kind of gives away our answer to the last one anyway, but we'll go ahead and do it anyway. Part D. Neha, what'd you get for part B? Or D, I mean. And by the way, guys, you got to pay attention to what they say in the word problem. It says, write an expression BOT that references the number of bats in the cave at T minutes. They might put X minutes or N minutes. If they put X, you got to use the letter they ask for. So that would have to go right there, right? So whatever letter they give you, that's the letter they want you to put there. And here also. But they would kind of give you a clue because they'd also have to write it there themselves as well. But anyway, so that's that. Now we're going to take it up to some other types of questions you could be asked. Let's take a look at part E through I here. All right, so we're back on my problem, right? So flip your paper back over to example 2. Okay, now it says use your expression from part D to calculate B of 2. So that means I'm going to take the thing that I wrote in part D and I'm going to plug in 2. And so that would look like this, right? 500 plus the integral from 0 to what? 2. Good. Of ET minus LT. Huh? Yeah, we're on the other side of the sheet now. All right, and once again, I think I'm just going to wait until the end to calculate stuff, but there you guys go. Now, what does b of 2 represent? For this, I'll take a hand. So when somebody tell me what that represents? Yeah, 2 hours, but go ahead, Pearl.
The number of bees at 9 a.m. I think it would be 9 a.m.
Okay. Yeah, nice job. The number of bees that are in the hive, I think that's important. The number of bees that are in the hive at 2 a.m. Because if you just say the number of bees, that it could be, what, is that the number of bees that left? Is that the number of bees that went in? What is this? The number of bees that are actually physically in the hive at 9 a.m. So the number of bees in the hive at, now you could say this, at t equals 2, just to be safe, but I like how Pearl contextualized it. She said that means 9 a.m. You guys have seen on the FRQs that we do, when you interpret something, you have to have 3 things: input units, output units, and context. So here's your output units. Here's your input units. I guess you could say hours to be specific. And the context is bees in the hive. Bees in the hive. All right.
I have a question. Wouldn't it be E2 minus L2?
That's a good question. So the answer is no. And that's why actually, I think a lot of times when they do the setup, they'll tell you to put X in, and so your X would go here. But this is just going to stay the same. The reason for that is because when you're integrating this, you're integrating something that's changing. The rate at which bees are coming into the function and the rate at which they're leaving is changing over time. So these are functions that change as time changes, and when you're integrating, you're adding together all that change that's occurring. If you just put a number in here, you've got one rate at that time and one rate at that time, and you're going to get basically you're just going to get a number answer, basically. It's going to be a solid number instead of a function. So I don't know how to answer that. But basically, no. It only goes to the top of the input. So, all right. Next one. Explain what the following expression means in the context of this problem. Let me see if someone else wants to try real quick. And if nobody else wants, I'll come to you. Okay. So, Pearl, what does that represent?
I think it's the number of bees left in the hive by 10.
I think I know how you got that, but that's not it. But I'll still give you a point for trying it out. Matter of fact, I'll give you one for the last one anyway. Anybody else want to take a crack at it? Yeah?
Isn't it the total number of bees in the hive at t equals 10 to t equals 2?
You're pulling the input units in, I like that. But I don't think we're quite there yet on the interpretation. Good shot at it, though. So let me point you guys a little bit in the right direction here. What does B of 2 represent?
The number of bees at 9 a.m.
The number of bees in the hive at 9 a.m., right? So what does B of 5 represent?
The number of bees at 12 p.m.
So B of 5 represents how many bees are in the hive at 12. B of 2 represents how many bees are in the hive at 9. What would that mean if you subtracted that? It's kind of a difficult thing to answer, but let's think about it this way. Back to the restaurant example. How many people are in my restaurant at noon? How many people are in here at 9? If you subtract that, what does that tell you?
The number of people left, how many they were over.
What? Okay. So it tells you how much the population in your restaurant changed over that time interval, right? So like, let's say, for instance, I have in my restaurant right now 40 people, and 3 hours ago I had 30. What's the total change in the population that I had?
Are you asking?
I had 40, right? I said I have 40 now, and I had 30 a couple hours ago. How much did the population change over that time period? We have a net change of 10. Now, does that mean that a lot of people could have came in and went, but a net change, it's the total difference. It's kind of like the difference. You guys remember a secant line? The secant line is not the slope of your function, it's the average slope. Well, this is like the average change that's occurred. You went from 30 to 40 over that time period, so that's a net change of 10 people. So we call it, so just so you guys know, this here is what we call the net change, or just to be less fancy, you could say the change in the number of bees from t equals 2 to t equals 5. Or you could say from 9 o'clock to what? 12 o'clock. So basically it just tells you the fancy word there is the net change. If you want to throw that word in there to be fancy, you can. But I think it would be fine just to say the change in the number of bees in the hive. We should probably add that, in the hive, from 9 a.m. to 12 p.m. Okay? Over that time period, it's basically like if you took a snapshot of how many bees are in there at 12, how many are in there at 9, what's the difference? And so as Angie said earlier, it's just the difference. So I think that could have been an answer too. You could have said it's the difference in the number of bees that are in there at noon versus the number of bees that are in there at 9. That would be a fine interpretation. You should. You should. All right. Let's do another one. Can I erase?
Yes.
Okay. Next thing says find b prime of t. So check this out. This is b, right? We found it in part D. Now, they're asking me to find the what here? The derivative. So let's do that. B prime. What's the derivative of 500? It's gone. We don't care about that. That's not a rate of change. They're just telling me how many bees were in there at the beginning. Is that ever going to change? No, that's what it is. That's how many bees were in there at the beginning. That will not change. And so it has no rate of change. But this does. There is a rate of change of the area under the curve. It's changing based on, you know, the rate in versus rate out. So what's the derivative, though, of an integral? It just cancels it out, right? If you take the derivative of this, it just leaves you with this. That's it. So the derivative of the population of bees in the hive at a given time is basically the total rate of change of the population of bees in the hive at a given time, which is the rate in minus the rate out. That should make a little sense, right? Rate in minus rate out is the total. So let's go ahead and take a look then at part I. Find b prime of 2. So that means I'm going to take my expression that I just found earlier in part H, and I'm just going to plug this in. And now, Graydon, we are going to plug it right in. Oops. We're going to have to calculate that on our calculator. I'll come back to that in a minute. Okay. I think we still have to do part E as well, right? So we need to do E and we need to do I on our calculator. But let's do this and interpret the result in the context of the problem. What does E of 2 represent? Can somebody tell me what that represents? E represents the rate at which bees are entering the hive. So E of 2 means that's how fast bees are entering the hive at 9 a.m. Okay? What does this mean? That represents how fast they're leaving. So what does this whole thing represent? If you do rate in minus rate out, what do you get? rate of change of the number of bees in the hive at 9 a.m. There we go. So this is the rate of change of bees in the hive at 9 a.m. Now, if I get a positive number, we should probably just do this. I keep putting off the calculator. Let's just do it real quick. Let me bring up my calculator here. I don't think I can move. There we go. All right, so I'm going to calculate it. I don't want to put this off anymore. I want to do it. So, good news, it's already stored into my calculator. I haven't changed it. You guys, you've changed yours though, so don't type the functions in again. So I'm just going to do e of 2 minus L of 2. Now, which function did I call e? Y1. So I'm going to do y1. There's y1, parentheses 2. Just type it right in, right? Minus y2, parentheses 2. Let's see what we get. Negative 16.629. And if I rounded that to the nearest, I wonder for our rate if we can have, I think it's okay when you're talking about a rate to have thousandths because you do have the factor of time involved. So time can be decimals. So now if I rounded the thousandth place, that 9 becomes a 10. So that bumps the next number up to 3, right? Now, the rate of change of bees in the hive at 9 a.m. is this. But what does that mean if the rate of change is negative? It's what? Something about the slope. It's decreasing. What's decreasing? That's right. If my rate is negative, then the number of bees is decreasing at that point in time. So I think we should probably add that here in our interpretation. This is a good answer. You get full credit for this, but a lot of times they'll want you to contextualize it a little bit more. So what we can say is, go ahead and draw an arrow to this and put the number of bees is decreasing at t equals 2. Since we got a negative rate of change, that means the rate at which the bees are leaving the hive is greater than the rate at which they're entering the hive. If this number is bigger than this number, you get a negative, right? So if the rate at which the bees are leaving is greater than the rate at which they're entering, then your rate of change is negative, the number of bees is decreasing. Okay? All right, let's continue onwards here. All right, what is the average rate of change of the bees in the hive on the interval from 0 to 10? So, what is the average rate of change? Of bees in the hive. How do you find an average rate of change? We've learned two averages, right? There's the average rate of change, and there's the average value. Okay? Average rate of change is this. Average value is this. Remember that? This is the average y value. This is the average slope. Okay, so what are they asking for? Average value or average rate of change? Okay, so here's what they want then. They want us to find what is b of 10 minus b of 0 over 10 minus 0. So how many bees are in the hive at 0? 500. We have to figure out b of 10. So let me do that really quick. B of 10 is 500 plus the integral of y2 sorry, y1 minus y2 on the interval from 0 to 10. So I'm just plugging 10 into the original b function there. So we end up with 587, which would be rounding to 588 b's. Give me some units. What are my units for this? What's the top? B represents bees in the hive. What does the bottom represent? Time. So this is bees per minute. Is it hour? Oh, you're right, it is. So what's the average rate of change? The average rate of change is, on the total interval from 0 to 10, did the average number of bees increase or decrease over time? It increased, right? We went from 500 to 588 over a 10-hour period. So your average rate of change was an increase. So we end up with a positive average slope. Okay. Last question. I know I'm taking a while here, but try not to bore you guys too much. Here we go. Last one. This is the last one, right? Okay. Okay. So what's the average value? What's my setup for average value? Hold on. Good point. I'm feeling weird. I remember I had this trouble last year as well. Hold on a minute. You're right. Thank you, sir. All right, so I'm going to calculate this really quick on my calculator. So here we go. We have 1/10. I'm going to put that in parentheses. And then I'm going to do math 9, and we're doing y1 minus y2. I think we're going to have an interesting thing occur here still. I think we're not out of the woods yet on this weird stuff that I'm having trouble with. But I'll show you what my thoughts are in a second. 0 to 10. All right, so there's that. Now let me ask you guys this. Look at my answer. 8.7. Let's just round it up. What are we going to say? How many bees is that? 9. An average value, the average Y value is 9 bees. Now does that sound right to you? Is the average number of bees in the hive 9? I mean, think of all the answers we've had so far. They've been in the 500s, haven't they? So here's the issue. This is the average value just of the net change. So the average net change has been 9 bees. So what's the actual average number of bees in the hive? 509. 509. So this is the average change in the number of bees here, the average amount of bees in the hive due to the in and out that's been going on. But we started with 500, so it's 500 plus 9, so it's 509 would be the average number of bees. So I hope you guys kind of are following my thinking. That's kind of like a weird question. But all this tells you here, this tells you the total change has taken place in the hive. This tells you the average value of based on the rate in and out. So if you add the original amount, that tells you the average number of bees. Yeah.
Does the average number of bees matter for this question?
What is it asking?
It's asking for the average value of the number.
It's asking for the average value of the number of bees in the hive, and I think that the initial value affects that. Yeah. So because I would have a problem. We're talking about hundreds of bees here, right? I would have a problem saying, yeah, the average number of bees has been 9, right? So something's not right, and the reason is because that's the average net change. But oh, I did it again. I thought we got to 52. I thought that was a long time. Sorry. All right. Well, we have the video. your homework is going to be to finish up the back of the worksheet. Plus, I'll probably have like an FRQ or two that's kind of like this stuff for you guys to work on. Okay. I think I'm going to ask you once again to do your FRQs though, just on a separate sheet of paper, not in the book, because I'm going to grade it like homework thinking and not like a FRQ.